Hi everyone. Today we're kind of continuing what we started yesterday with trigonometry. Yesterday we reviewed SOHCAHTOA. Today we're going to continue with the SOHCAHTOA theme, but we're going to talk about inverse trig ratios. You did these last year, but the inverse trig ratios are used anytime you're trying to find an angle, and you might want to kind of underline that or highlight that for yourself. This is what I want to pop out in your brain anytime a question is asking you to find an angle, to calculate an angle. You're going to be using what's called an inverse trig function. So you can see in this picture down below, I have two side lengths listed, and I'm being asked to find the angle. Whereas if you remember from yesterday the problems I gave you, you had an angle to work with, and then you had one side length, and another one might have been x. Okay, but now you have two of the side lengths and you're looking to work backwards and find the angle. Okay? So let's go ahead and do this example. Again, you'll notice that you've got two side lengths given to you here and we're being asked to find this angle. So the first thing I would do is label the side lengths in terms of the angle, meaning which pieces of the triangle do I have? Well, this 14 is right next to the angle that I'm looking for, so that would be my adjacent side. And then the 21 is across from the hypotenuse, is across from the 90, which makes it the hypotenuse. Okay, so I've got my A and my H. Think back to SOHCAHTOA. That's the cosine ratio. So when we set up trig functions, we always do cosine or sine or whatever of the angle. So I would say cosine of x is equal to, and then when I set up my fraction, it would be adjacent over hypotenuse, so that would be 14 over 21. So this time, instead of having my x here in my fraction, I've got my x here in my angle spot. Well, what I want to do is ask my calculator, hey calculator, what angle has a cosine equivalent to this? Because remember that when you type into your calculator, cosine of an angle, it gives you a decimal. And this 14 over 21, that could be converted to a decimal. So I want to know what angle would have this as its cosine. Okay, would have this as an equivalent for its cosine. So here's what you do. You use something called the inverse cosine, which the inverse cosine looks like the cosine, but it has a little -1 above it. I'm sorry, my handwriting is really messy today. And you get to that by doing the second button plus the cosine button. So if you look at the cosine button on your calculator, it probably has this written on top of it that you have to use your second button to get to. So you're going to hit second cosine to get this to pop up. And then it's going to probably open up parentheses. You would just type in 14 divided by 21. Let's see, I'm going to need to calculate that myself. So I'm going to hit second cosine. So I hit second cosine of 14 over 21, and I got 48.189. And with these, usually just rounding to the nearest degree is fine. So I would just round that off and say that's going to be 48 degrees. Okay. So just to verify here, 14 over 21 as a decimal, if I just type in 14 divided by 21 in my calculator, I get 0.6 repeating. So if I do cosine of 48 degrees, this is not something you'd have to do for every problem, but I just want you to see why I did. Cosine of 48 degrees from my calculator would be 0.669. So you can see that what your calculator is telling you is the closest thing we have to this being a cosine is 48 degrees. Okay? So anytime you're being asked to find an angle, you're going to be using inverse cosine or inverse whatever trig function. It can be inverse sine, it could be inverse tangent. We chose cosine because we had adjacent and hypotenuse. Hopefully that makes sense. Okay, so take a look at all of these. It says find the measure of the angle. So again, anytime you're being asked to find the measure of the angle, I want you thinking inverse trig. Okay? So cosine of some mystery angle is equal to 0.914. So in my calculator, I'm going to hit second cosine. And I sort of wish I had done this video with the document camera so I could show you what I'm putting in my calculator, but maybe I'll post a second video on how to type it in your calculator if you guys are feeling stuck. So I would hit second cosine of 0.914. And again, you wouldn't have to write this out necessarily, but I just want to show you what I would put in the calculator. And that's going to give me, if I round it to the nearest degree, 24 degrees. Okay, so for this one I would say inverse sine of 0.829. And again, I'm going to round. And I get 56 degrees. And finally, this one I would do inverse tan of 4.705. And I get 78 degrees. Okay, that's all there is to it. So really the big takeaway today is when you find the measure of the angle, when it's the angle that you're looking for, you're going to have to use this inverse nonsense. Okay, the word problems in this section, we're going to start introducing the concept of angle of elevation, angle of depression. What I want you to get with these is that it's always measured from a horizontal line. Okay, so angle of elevation means if you are standing on the ground and you turn your head up, okay, and I try to illustrate this in class, so we'll probably talk about it again tomorrow, but if you turn your head up, it's the angle at which you're turning your head upward. Okay, that's your angle of elevation. Same thing, angle of depression, and by the way, this looks like a very unfortunate picture over here, but angle of depression, if you're staring straight ahead and you turn your head down, that's the angle of depression, okay, or angle of decline, okay. A lot of people want to put the angle of decline here. That's not what you want. You want it to be always measured from that horizontal line down. I like this picture down here in the lower right corner that I've given you because it sort of shows both of the angles here. You've got the guy looking down at the ladybug, so to measure the angle of depression, that's really the angle that he's turning his head downward to be able to see that ladybug. Okay? The ladybug then would be looking at an angle of elevation because it would be the angle that the ladybug is turning its head up to look at the man. I don't know why the man and the ladybug are looking at each other, but it's a good illustration. What I want you to notice, and maybe I'll have some geometry flashbacks here, but these are both horizontal lines, right? And then I've got this transversal coming in through here. So these angles here and here, those are what we call alternate interior angles, meaning they're congruent. So anytime you have both an angle of depression and an angle of elevation, those angles are going to be equal to each other. Okay, that's a big thing for you to get because there's going to be times when you're given this angle, but you'd rather have it down here in this triangle, and then you can shift it because those angles are always going to be congruent. Okay, let's look at an example like this with some brilliant artwork once again. An airplane pilot is preparing to take off. According to air traffic control, he must reach an altitude of 35,000 feet by the time he's 150 miles from the airport to avoid collision. At what angle should the pilot ascend? Okay, so I'm going to take this piece by piece here. So here's our airplane taking off from the airport. So the airplane is taking off along this path. It says he must reach an altitude of 35,000 feet. Altitude is straight up in the air, so this is my altitude. Okay, so I must be 35,000 feet in the air. Okay. By the time he is 150 miles from the airport, that's ground distance. So that means this needs to be 150 miles. And I want to know at what angle should I ascend? Ascend means like to go up, the opposite of descend. So the angle that he's going to ascend at is down here at the airport. Okay, it's the angle that he's taking off at. So what is this angle? So I'm going to mark that with my X because that's what I'm trying to find. Okay, before I can start this one, I want you to notice that this here is measured in feet and this is measured in miles. Okay, that's a problem. You do need to convert here. You need them to be in the same units. I don't care which one you convert. I'm going to convert this 35,000 feet into miles. And I'll just do this work over here. But there are 5,280 feet in a mile. So I'm going to take my 35,000 and divide by 5,280. And I get 6.6 if I round. So that means I'm going to take that 35,000 feet now and call it 6.6 miles. So that these two things are now in the same unit. Okay? So that is important. I'm going to try to get rid of just that piece. Let's see. Okay, so I moved some of that other junk out of the way. But we are working with 6.6 and 150. So this is my angle I want to focus on, which means from this angle, the 6.6 would be my opposite side, and the 150, because it's right next to it, would be my adjacent side. Okay, so I'm working with O and A. That's the tangent ratio. So I would say tangent of my mystery angle is equal to 6.6 over 150. So what I'm trying to figure out is what angle would have this as its tangent. That's where you ask your calculator. Hey calculator, what angle has a tangent equivalent to this? And so remember to do that, you're going to type in tan negative 1 of 6.6 divided by 150. Sorry, I'm just trying to do it along with you. And I get about 2.5. So that's 2.5 degrees that airplane should take off at. That seems really tiny, but if you think about it, an airplane is going to take off at a really tiny angle. If it took off at a 45-degree angle, that'd be pretty scary. Okay, so that would be my angle of ascent, that 2.5 degrees. That'd be that right there. Okay, let's try one more. Okay, so let's give this one a shot. A construction worker is on top of a 40-foot tall building and looking down at his assistant at a 24-degree angle. Okay, so this is where he's looking down to see his assistant. Okay, this is where I want you to be careful with angle of ascent and angle of descent, because a lot of people want to say this angle here is 24 degrees. But if I say that he's looking down at a 24-degree angle, that means he's turning his head down 24 degrees. So if this is where his line of vision was to begin with, this angle is the angle that's 24 degrees. Okay, it's the angle that he's turning his head down from horizontal, always starting from horizontal. Now I want to know how far away from the building is the assistant. So I want to know how far away is he down here. Okay, the problem you run into here is that this is your triangle here, and that 24 degrees is outside of your triangle. Well, remember what we talked about with the alternate interior angles and the angle of descent? If this is 24 degrees out here, that means this angle down here would also be 24 degrees. So that would be like if the assistant was turning his head to look up at his manager, he'd be turning his head up at 24 degrees as well. So I can take that 24 and shift it down into the triangle. Okay, you just don't want to put the 24 here. Okay, that's going to get you the wrong answer. So now that I've got that set up, this is actually not an inverse trig problem. And I know that because I'm not missing an angle, I'm missing a side length. Now I want to say, all right, the 40 is my opposite from the 24. My x is my adjacent, so this is again going to be a tangent problem. I would set up tangent of 24, because this time I do have my angle, is equal to 40 over x. Okay. From my calculator, tan of 24 is 0.4452 equals 40 over x. From here, I would put this over 1 and then cross multiply. So I would end up with 0.4452x equals 40. And then I'm going to have to divide by the 0.4452. Divide by 0.4452. I'm going to come out with pretty close to 90 feet if I round upward. Okay, so x equals 90 feet away from the building. Okay, that would be this distance here. Okay, so hopefully that made sense. There is a check for understanding that I'd like you to fill out when you're done with this. Just a couple of practice problems for you. And then homework for tonight is Lesson Master 10-2B that was in the packet I gave you yesterday. If you don't have that packet or if you're missing that sheet for whatever reason, come on down to my classroom and I have them for you there.